And our last presentation is by Yi-Rong, Chen, and Stephan van Gasselt, and I believe they are joining us online.
Yes, one of them at least, if you can hear me. Hello?
Yes, we can hear somebody.
Okay.
Go ahead.
Okay. Are you putting the presentation on?
Are you sharing your screen?
Oh, no, actually not, because the
So
guidelines
so we
said
can
that
do
you're
it
going
here,
to
I
share.
believe. So can we get his
Sorry.
presentation up?
Well, I can arrange a sharing, but I need to dial in.
Or allow
first.
him to share, yeah. So it might be local here.
So,
Can we allow him to share his screen? Would you prefer to share your screen, or would you like me to bring it up here?
well, I prepared for both actually, but
Why
with
don't
the
you go ahead and
guidelines.
try
But
sharing your screen, and let's see if that works.
okay. Does that work? I'm sharing right now.
Not.
Okay, give me a second.
Okay, hold on a second. Let me. Zolt, we only have 3 presentations for session 1 here.
Well, okay. Well, I uploaded actually, so that was fine. So if I can, give me a second. So can I can, what is it? More action? Can I have no access control to sharing anything. That is the problem, I guess.
Zolt, can you?
Okay, oh, wait a second. Let me try this one. That should be working now.
Yes.
Sorry.
There we go.
So, and how can I do this? Full screen? Okay, full screen, right?
Yes, I think that's as big as. I mean, we have the Teams meeting, but it's good enough. Let's go.
Okay. Well, after 2 years of COVID, still some troubles with online presentations, right? Well, okay, first of all, thank you for opening this conference for virtual attendance. Actually, very much appreciate that, and for giving us the opportunity to give this presentation online. So I'm the second author here. My name is Stephan van Gasselt, and I'm currently at National Chen University here in Taipei. So early morning here. Yi-Rong was my student who's been conducting much of the developing work and so on. Okay, so let's get started. So this talk is about tactile or tactual maps, if you will, maps for blind and vision impaired people, and more precisely actually for the blind and low vision community, which is a subset. Okay, just some numbers. Okay, so we know that according to WHO, 30% of the global population suffers from some form of vision impairment. Okay, so many of us have glasses, so that is already a vision impairment in a way. Well, there are up to 45 million blind people globally. The number is not well constrained due to well lots of effects, but the point is that this number is increasing despite better medical supplies and treatment and opportunities. This number is still increasing because there are more people on this planet, and many people in developing countries don't have any access. Okay, so. And there's another effect that tens of millions of blind and low vision people have no access to effective support services and assistive products, right? Navigating through a city, for example. So much effort was actually focused on maps, tactile maps for navigation in environments. But the thing is that tactile maps alone is not what the BLV community needs. They need hazard avoidance systems and so on. So this is a bit of a different playground, actually. But the main point is with this impairment, people have difficulties accessing good education usually, and there's also higher unemployment rate connected to that. So for people who can be treated, like with glasses or with other medical treatment, so we know that we are actually depend on visual input that we need for stimulation and orientation. But BLV community people must rely on substitutes, right? And these substitutes are usually tactile or audio. So the advantages of this tactile feedback is there's a better spatial decision making associated with that, a better environmental knowledge, and also independent travel, as we can imagine. One of the things is that became quite apparent if you read the literature is that many developments made by sighted people are more technology centric, which means like, cool, we have a 3D printer, we can do something, and maybe somebody can use it, right? So it feels a bit like that. This is a bit frustrating. So 3D printing technology is good, of course. It improves the situation, as research has shown. It helps actually building cognitive maps by shaping spatial information. So this works quite nicely. So there's technology to make better use of spatial information, and much work has been focused in orientation maps, including real-time navigation. So we were actually more interested in looking into educational maps. How much information can we put into thematic maps, thematic tactile maps, not just a building and a road, but more information. So it might actually be the right time to do this because the technology is there. So objective requirements. So the idea is to build a workflow using map printing device, whatever that might be, that allows to generate and print thematic 3D maps with open source data, right? Extract data from public sources, not open source, but from public sources. And the idea of that, the intention of that is maybe we can create something one day to put into like community centers, education centers, or so on, where people can print their own maps or their own educational material in an automatic way, of course, right? Which is always, of course, a difficult thing, in particular in cartography, as we all know. So I don't go into the detail of this flowchart here, but the point here is, so we need to extract some data from some sources automatically and do our cartographic abstraction in a broader sense. And then we need to get in touch with the blind and low vision community and communicate and iterate and start over again and iterate and start over again, okay? So that is the idea. But before we can start iterating lots of things, we need to produce something first. Okay, so we had some expected challenges, and these were, of course, data exports, imports, how to merge different data sources. Well, not technically, but well, because of different definitions, different abstractions, and different timestamps, and so on and so on. How to transfer cartographic variables into a tactile domain. There has been some research, but it's also not finished actually. Which standard to use? What about consistency? And what about information density? That is what we were mostly interested in, okay? And we have limitations, map scales and extents, of course. So we have limitations in print size. That's due to the printer, whatever printer we will choose. There's a limitation of perceivable detail. That is, well, a problem of humans, let's put it this way. And a limitation of variable overloading. And what I mean by that, I show in a second. So, so there is a limitation of perceivable information depth and map complexity in a way. So we can solve limitation of print sizes, but by just tiling print maps, right? So there are printed plug connectors, and we can make, well, maps as large as the empire, right? So that would be one way, and it works actually. And the other part is this limitation of perceivable detail, and we have no solution to that. Okay, there are physiological limits, and that can also not be solved by better printers. And this variable overloading, well, that's the point that I can put ordered or quantitative information into a variable, and can put like four stacks of that if I want to into one, let's say, point symbol. And I cannot do this in tactile environments, right? Very clearly. So I have texture and size, maybe, we thought. I come back to this later. And that's it. So tools might not be optimum right now, but they are not the limitation. Okay, humans are the limitation. So underlying principle, sighted people read the entire map at once, and that is, well, that is kind of obvious, but still it's a different thing if you actually experience this in a dialogue. Okay, so we see our variables, and they might be selective, so we just see them and we just react to them spontaneously. We don't have this for tactile maps. So these maps are really scanned by the fingertip, and then you see that this model is built up in the brain. Okay. Yeah. So we cannot just transfer some visual map to some tactile thing and hope it's fine. So what we lose definitely is information about value, hue, or saturation, if you want. But on the other hand, we thought again, we gain some additional freedom by introducing height, printing heights, right? So that should become a new variable. And for the rest, orientation, shape, texture, and so on should also work. So we used OpenStreetMap data because, well, we want to have a low-cost solution for community centers and so on. Open government data, that is quite nice here in Taiwan because everything is openly accessible. The policies are wonderful in that respect. Surveying data and some other data that is freely available. One of the challenges is, of course, cartographic labels because nobody speaks English. Well, I mean, not operationally in schools. So we need to come up with a transcription of Chinese symbols, right? And well, we didn't have to invent this. This was done because, well, there is a braille system for traditional Chinese, which is different from simplified Chinese. The way they here in Taiwan are typing Chinese characters are completely different from the way they type it in the mainland China. Okay, so there's a phonetic translation table. And you see the symbols here on the right-hand side. So they can be modeled as point symbols, apparently, using some programming, scripting, and the right use of some CAD systems. And we are using OpenSCAD because it is a solid modeler, which we need, and it is scriptable. And it's open source again, so that is fine. It fits into the workflow idea. Map symbology, well, there are lots of guidelines and lots of national guidelines, so we picked the Australian one. Why? Well, just because they have some experience with city maps. So we thought, well, this might be a good one, actually. So we have some criteria, width criteria, height criteria, limits, and so on, and we try to incorporate that. For the device, well, the conventional or the traditional 3D printers were always a bit like disappointing because they had a texture due to the printing process already. It was quite rough. You can get rid of this with manual work, but that was not the idea. And we are quite happy that we can actually use resin printing devices. And they give a very smooth surface. Everything is nice. This is a quite low-cost model. We need a curing device as well, but all of that is below 1,000 US dollars, and it's even cheaper now. That is the price of 2021. So results. Well, some results. Yeah, map layout. So the limitations is the print size, apparently, and with that comes, of course, the map scale limitation, also clearly. So this is not too large for one printing tile. So of course we have to come up with an idea of putting tiles together to cover a larger area to put more dense information into this. OpenStreetMap extraction works quite nicely with the Overpass API. However, the main problem is not the geometry. The main problem is that in order to extrude a feature later automatically, so it can be felt actually by the fingertip, we need to convert things to polygons, okay? And all these features are not actually polygons. So this was quite some developing stress, let's put it this way. But we come up with a simplified map just as a conversion from OpenStreetMap. But we also thought about using the same, oh, give me a second, yeah, sorry. Same area for other thematic information. So our legend, so map symbology can be transferred, and you see a rendering here from OpenSCAD with the Braille system and the legend and so on. So that is also working quite nicely. On the left-hand side, this is the normal OpenStreetMap with some Braille information also at the front with the title and so on and so on. You see this information, also scale information and so on. Printing on the right-hand side in pink. If you think you see some bending there, that is totally correct. That is a thermal problem or desiccation problem, actually. This is a land use map that we extracted from government data, so it covers the same area, but in different aspects, in different thematic topics, so to say. So we stack this by different maps. And if you ask yourself where the legend is, well, this is detached, okay? So we have the map information on one tile and the legend on another tile that is separated from that. So we can reuse this in a way. So here, this is a tiling scheme. They fit together, although it might not look like this, but this is all one area, just different colors because we got sick of looking at the gray ones. And well, validation, well, this is still work in progress. So of course we talked to the community and we gave them some tasks and so on. They have some experience with thermoforming tactile maps, which get really ugly after a year of use, in particular in primary schools or in schools, junior high schools and so on. Everybody's touching them. So so we gave them some legend reading tasks, asked them about their experience and orientation and so on and so on. Interesting enough, height difference is not really working very well, okay? And that is also contrary to what we have seen in the literature, but we need a more representative study to confirm that. Widths, we took 4 road level widths, does not work either very well. It works, but it needs training. But point identification and so on is easy, that is clear. So feedback, basically they like the texture and they like the feel of that, the haptic feedback. They are not familiar with height and width variation. They would like to see some zoom, which I find funny. I don't know how to implement that, but it's an interesting thing to think about. Okay. And yeah, scale and map size is of course a problem because we don't cover larger areas here. There are some unexpected challenges and operational limitations. So there's some differential hardening curing problem, highly temperature sensitive, in particular here in this environment, which is quite humid. It's getting a bit problematic. And well, the resin is also not the safest material. It's bioactive somehow, so there are still studies going on. Yeah, so so this LCD 3D printing technology works actually quite well and long-lasting products, right? The scale is not really what we need. We need to come up with a better idea. Interesting enough, visually impaired people are not very familiar with texture, but not so much with height and width. So we want to investigate this further. And the whole automatization, the conversion, automatic conversion is far from being perfect at this point. Yeah, so last slide. Of course, we need more BLV community work. We want to also get in touch with other researchers working in this domain. There is none here in Taiwan other than what we have been doing. ICC, they have a commission. We are in touch with them. That is quite nice. Yeah, and we want to spend more time actually on investigating how tactile variables are perceived by the community. And yeah, that's it. Thank you very much.
Thank you for that very interesting presentation. We do have time for questions, either in the house or online. Well, I have a question. So I'm not an expert in tactile maps, but I was struck by the difficulty that subjects had with height and with width that you mentioned.
Mm-hmm.
And I was wondering if the concept of icons, where we've developed so many icons that are visually distinct, but what would an icon look like that is tactilely distinct? And have you thought about that and testing different icons for use?
Yeah, it's a good point. So, of course, in the publications, you will find discussions about icons. But in order to make an icon distinguishable, you have to have a certain size. And you don't have so many options there. It cannot be too complex. We started to look into this, but we also saw that the map is easily cluttered. So this is why we just have a very tiny point, for example, for bus stops. Okay, this is just a very small point. We need to investigate this further very clearly. Yes, yes. But I fear that at that scale, they might be hard to distinguish.
I can see they'd have to be large, so the content that you'd be able to provide would be limited by that.
It works nicely with squares and circles and these kind of primitive shapes. And you can add some points on top of that, okay, like with the Braille symbols. But that's about it. That was our experience thus far. I'm not saying that this is the final word on that. No.
Right. Okay, thank you.
Thank you.
I think we have a question in the audience.
Yeah, thank you for the presentation. And I think this is a very timely topic. We're seeing more of these tactile maps. I think, Barry, this is more a comment to your question about symbology. I don't have a lot of experience, as you said, in this, but I have some colleagues that do. There's a couple of national mapping agencies that I work with. One of them is Swiss Topo, which is the federal agency for topography, and the National Mapping Agency in Switzerland. And they've created a tactile map of some of their national, their small scale topographic maps.
Yeah.
One of the problems they run into is real estate, as you talked about, is the symbology has to be big enough for the tactile reader, the BLV people, and it doesn't leave you a lot of space. But they are making progress in this, and they are moving into larger scales. The Dutch Cadastre in the Netherlands, which is the National Mapping and Cadastral Organization, is also working in this area. And there's a paper that was done by Dr. Vincent van Altena at the Geospatial World Forum earlier this year in May on this subject. And they actually presented in the plenary on this, and they ran into similar issues, but they are working towards trying to go to larger scales. Both of them had success with linear features. So if you think about a topographic map, it has a lot of linear features, and they've also done a lot with symbolized lines where you've got dots and dashes. And I think to our colleague's work here, where he recognized that it seems like the raised area features and the width is a challenge, but the texture, yeah, they can feel the line work on the symbolized lines.
Absolutely, yes, that's correct. Yeah, so they can trace the line with their fingertip if the spacing is not too wide, and there you can incorporate lots of different textures. Actually, that's true. Yeah, but not
If I
unfortunately
could,
not. Yeah,
I'm
sorry.
sorry, go ahead.
No, I'm just saying. So unfortunately, not all elements on a map are linear. Okay, this is where we struggle. The linear features are actually fine. Yeah. So yeah, please go ahead.
Yeah, I think the difference is you're doing work more on thematic data, which is going to be more areal features, whereas in a topographic map, traditionally, you have a lot of linear features. There are area features, but so one other comment I wanted to tie in this ties in with the last session that we had, which includes diversity, equity, and inclusion. And again, I think this is an important area. One of the things in the paper that I mentioned with the Dr. Vincent Van Altina is he worked with the visually impaired and worked together on what was the map product that would be most useful to them. And I think that goes back to the last session where we're talking about you need to be inclusive of these organizations. Don't just map for them, map with them.
Well, absolutely. That's the whole idea behind that. But we need to start with something because most of them, and we are talking about students, and because that's our target group, they know these 3D relief maps that you also know, and they can work with that. But other than that, they don't have so much experience with map reading actually. So we need to start with something, and they need to get the message first to tell us how to improve, what does not work. And so that's what I meant in the beginning. It's an iterative process, definitely.
Yes, it takes time to build these connections, but it sounds like really interesting work that you're doing. And I think there's communities there that you're getting in touch with as well.
Yeah. Thank you.
So thanks to all of our speakers and thanks to everybody in the audience as well. I think we are just about out of, or a little bit over time. So we do have a half-hour break, or now only a 25-minute break. I think there's going to be some free refreshments served. So please partake in those, and there will be another session here starting at 3:30.